Welcome back to The Explainer. Today we're diving into this absolutely fascinating historical divergence and how we actually build the digital world. We're looking at how two radically different philosophies, literally two completely distinct ways of thinking about software, somehow emerge from the exact same fundamental web technologies. On one side, we've got an architecture built entirely for speed, the fast-paced associative chaos of the startup world. And then, on the flip side, we have an architecture designed for strict, uncompromising security for the independent creator. It's this wild contrast between moving fast and building fortresses, and we're going to explore exactly how this split went down.
Okay, so here's our roadmap for today. We're going to start with two paths, same tools, then navigate Balaji's startup idea maze, look at unifying nouns and verbs, meet the strict logical bouncer, and finally wrap up with protecting creator sovereignty. Let's jump right in.
Kicking things off with Section 1, two paths, same tools, looking at our shared foundation. If we rewind a bit to the early 2010s, tools like Node.js and JSON just exploded onto the scene as these totally dominant, foundational forces for web developers everywhere.
Now, what's so captivating about this era is the immediate contrast it sets up. We're looking at the exact same tools, Node.js and JSON. Because they were text-based, everywhere, and super easy to parse, they were incredibly adaptable. But that adaptability led to two entirely opposing mindsets, right? On one hand, developers treated them as rapid plumbing. The whole goal was to just connect things quickly, move fast, and iterate constantly. But on the other hand, those exact same tools were used to create these rigid, unified, structural environments. It's literally the same building blocks being used to build totally different houses based on what the architect cared about most.
All right, moving into our second section, let's explore the path of speed. This path was perfectly encapsulated and taught to over 250,000 students in Balaji Srinivasan's massively influential 2013 Stanford MOOC Startup Engineering.
So in this course, Balaji introduced this brilliant concept called the idea maze. And honestly, this idea totally shaped the Silicon Valley mindset for a decade. Imagine you're a founder, okay? You're standing at the entrance of this massive, complex, highly associative landscape of markets, unproven tech, and just endless micro-decisions. You're basically guessing in the dark. To survive this maze, you have to test and adopt rapidly. Your tech stack isn't supposed to be some pristine, perfect product. It's really just a flashlight to help you find the exit. So the course framed modern web technologies not as tools for building monuments, but as rapid systems integration tools, meant specifically to survive all that guesswork.
The whole philosophy of that era is captured perfectly in this one thought: getting something to work well enough for people to buy. That's it. You didn't need your code to be a flawless work of art. The focus was 100% on market viability and speed over architectural perfection. I mean, when you're racing against a ticking clock of limited funding, your only objective is to prove people actually want what you're selling before the money runs out.
And to hit that kind of speed, founders leaned on a really specific tech stack: Ubuntu Linux, AWS, Node.js, and JSON. In this context, these technologies acted as incredibly fast, lightweight plumbing. A startup engineer's main job was basically systems integration, taking all these disparate pieces, snapping them together like digital Lego blocks, and just shipping a product to consumers. Behind the scenes, this rapid plumbing was honestly often held together by digital duct tape and hope, but that didn't matter. It was all about testing market fit as fast as humanly possible.
Okay, let's transition to Section 3. Unifying nouns and verbs. This represents a massive pivot toward what we can call the path of sovereignty, and it's perfectly embodied by U.S. Patent 12.664.142, which is known as SeedTreeDB.
To really get why SeedTreeDB is such a breakthrough, think about it like a grammatical divide. Traditional enterprise software is fundamentally aggressively divided. It forces our static databases, which act as our nouns, and our active computing logic, which act as our verbs, to live in totally separate buildings. If they want to communicate, they essentially have to shout across a busy street. And this aggressive separation creates incredibly error-prone environments. Developers lose hours, if not days, debugging huge namespace collisions and programming mismatches simply because the data and the logic keep losing track of each other across that divide.
When you put standard software side by side with SeedTreeDB, the structural differences are night and day. SeedTreeDB's inventor, Kyle McLean-Smith, completely solved this crisis by taking those exact same tools from the startup world, Node.js and JSON, but he completely threw out the rapid plumbing approach. Instead, he used a JSON-like tree structure to unify data and logic in the exact same room. By putting the static nouns and the active verbs right next to each other into single, unified nodes within the application runtime, SeedTreeDB completely replaces the chaos of standard programming with pure, deterministic execution.
So, Section 4, the strict logical bouncer. Because you might be wondering, how do you actually maintain order when your data and your logic are suddenly living in the same node?
Well, take a look at how the interface module communicates with the parent node. When an event comes in, that parent node doesn't just wildly execute a command like some rapid duct tape startup script might. No, instead, it passes that event safely to the kernel function. Everything flows through this highly specific, controlled gateway. There's no unauthorized entry and absolutely no chaotic execution. Following the literal steps mapped out in the patent, a new child node is securely instantiated to hold new data. Then, and this is crucial, the identifiers of both the child and parent nodes are passed to that kernel function, which adds metadata to mathematically link them together. This mathematical link creates an absolute, unbreakable chain of custody for the data. It's an incredibly precise, sequential process that just completely wipes out the ambiguity we usually see in traditional web plumbing.
Standing right at the center of all this is what the patent calls the SYN kernel function, standing for thesis, antithesis, and synthesis. I want you to picture this function as an uncompromising, strictly logical bouncer standing right at the front door of your database. Step 1, the bouncer sequentially checks to see if a space is empty. Step 2, if it is empty, it seamlessly synthesizes the new data into that slot. But step 3 is the kicker. If data already exists in that spot, the bouncer firmly and violently rejects the input. It evaluates this logic before a single byte of data is ever written, entirely preventing accidental overwrites.
Which brings us to our final section, protecting creator sovereignty. We've gone through the math and the architecture, but why does putting data and logic in the same room and guarding it with a mathematical bouncer actually matter for independent creators? Well, when we rely on rapid plumbing to navigate the idea maze, we're basically accepting a certain level of chaos and error as a trade-off for speed. But if you're an independent creator or artist, your digital intellectual property is your livelihood, right? You just can't afford to have your work subject to the random whims of a chaotic server environment. By replacing that event-driven guesswork with a strict, unified architecture, C-tree-DB protects the exact digital intent of the author. This strict environment guarantees true sovereignty because there is absolutely zero ambiguity in how a creator's work is executed or stored. Your data cannot be accidentally overwritten. Your logic cannot be misaligned. It is legally and structurally bound.
Both of these philosophies were built using the exact same web technologies. One gave us the incredible speed to navigate the startup maze and rapidly prototype the modern internet. The other offers us an uncompromising, deterministic fortress that legally and structurally protects the human author. So, as we continue to build the digital future, what do we actually value more? Do we prioritize the associative speed of the maze or the strict sovereign security of the creator? Something to think about. Thank you so much for joining me for this explainer. Keep asking these tough questions, and I'll catch you next time.